Welcome to Explaining SDVoE to your IT team. This short course will explain what SDVoE does on a network, and this will help you and your IT team prepare for an SDVoE installation and identify SDVoE-related traffic across the entire network of your project. The SDVoE solution consists of two components, a hardware component and a software component. Now, the hardware component is what we call a system-on-a-chip integrated circuit, and we refer to it as the Blue River chipset. While the software part is an application programming interface, and we refer to this as the SDVoE API. Together, these two components combine to make a flexible, powerful solution, and with the SDVoE adoption of the Blue River solution, we refer to this as the SDVoE platform. You can learn more about the SDVoE API from the Unified API course here on Academy. You'll find a link at the end of this course. Also, if you're interested in developing your own control software using the SDVoE API, check out our developer program and why not become a certified SDVoE API developer. The API itself can communicate with the control system in one of two ways. The Telnet API interface, which uses port 6970 by default, although this port is configurable, and the RESTful API interface, which uses port 80 and 443 by default. But again, they're also configurable. It's possible for both to be used. However, check with your programmer or control software manufacturer to be sure. But most probably, your system will use the RESTful interface only. Irrespective of which API interface is being used, this traffic will always be unicast between the control software and the API interface. And again, you can learn more about each of these API interfaces in the developer program right here on Academy. What are you waiting for? There's a lot of stuff going on between SDVoE devices, from device discovery to control to audio and video streams, and these packets are determined by the control software and the API server, both of which are deciding how many and which devices they are talking to. Some could be broadcast packets, some could be unicast packets, others could be multicast packets. For example, tiny packets of data called hello packets are regularly sent across the network for device discovery to allow the API server to determine which endpoint devices are currently online. And this communication is done via UDP, or User Datagram Protocol, and that uses port 6969. Why not head to the Layer 4 Transporting Video Across a Network course to discover more about TCP and UDP packets. Each Blue River chip supports up to 4 channels of low-speed control data for IR and RS-232, for example, although an individual product may, or in most cases may not, use all 4 channels. Like other control data, this will be UDP traffic. It may be broadcast, multicast or unicast, depending on the API server's choice. Whichever it does choose, these 4 channels of data use ports 10,001 to 10,004 respectively. We know from the Certified Design Partner training that multicast traffic is assigned a separate range of multicast IP addresses, even control data. When transmitting control data via multicast, the API server will assign a set of multicast source addresses to each endpoint, and by default, the API server uses a range of addresses from 224.1.1.1 to 224.1.3.255, although this is configurable. If you haven't already qualified as a Certified Design Partner, then waste no more time and head to the Certified Design Partner training program right now. It's an essential core development track which will explain all the basics you need to know about SDVoE. The API server itself can also be discovered using a Layer 7 protocol called SSDP, or Simple Service Discovery Protocol. You'll recognise these as multicast UDP packets using port 1900 with a default multicast IP address of 224.0.1.188, although this address, like the others, is configurable and could be altered within the multicast range we looked at previously. There are two types of USB subsystems used by SDVoE endpoints. ICRON-based USB, which utilises ports 6137 and 6971 for unicast and broadcast device discovery and control, and this little fella, USB HID, or Human Interface Device. Now, this is managed directly by the Blue River chipset, and it uses unicast traffic on port 6973. Again, head to the USB Deeper Dive course here on Academy to learn more about these two USB subsystems. At some point, after all this device discovery, control, and USB traffic, surely it's time for Blue River to actually send some AV data. This is done using a modified PVP protocol, which you'll see as Protocol 75 on your Wireshark capture. Cryptic, eh? That said, the actual protocol we're using is our own Pixel Pipeline protocol, so you won't be able to decode the data. It's a connectionless protocol, so that means there are no port numbers associated with the AV transmissions. And because all AV transmissions are multicast, each endpoint is assigned a unique set of multicast source addresses by the API server. Now, by default, the API server uses a range of addresses from 224.1.1.1 to 224.1.3.255. This is the same configurable address range used for multicast control communications as well. It's important to remember, though, that each individual stream, be it video, audio, or control, has its own unique multicast IP address, even if those streams are all coming from the same endpoint. It's important not to confuse multicast IP addresses with the actual host IP address. All of this information is available in a one-page document that you can download right here in SDVoE Academy. However, if you're not watching this in the SDVoE Academy, why not? Only joking. Make sure that you check for a link below and register to get the document. Very important.